So pagi ni kita akan bincang complex number. So before we discuss the complex number, so first we must know dia punya asal unsur untuk complex number. So kita mula.
In this lesson, we are going to discuss about the introduction to imaginary number. We have already know what real numbers are. These are the numbers that can be represented on the number line. We also know that the real number can be broadly classified as the rational numbers and irrational numbers. Rational numbers are those can be represented as a ratio of two integers with no common factors. Irrational numbers, on the other hand, cannot be expressed as a ratio of two integers when expressed in decimal notation. They are non-terminating, non-recurring decimal. Are there any other kinds of numbers?
You refer to this one, mention we have real number. So this one is the thing that we have been discussed in the first week, okay, real number. So in general, we have two big sets, which is the rational, okay. So rational consists of fraction and decimal, okay, fraction and decimal. Another one, we have irrational numbers, which is not a fraction and then not a repeating or terminating decimal numbers. So kita ada dua group.
Before you answer that question, let us think about this in a systematic way. Kindly refers to the table. We have three columns. We fill up the first column with the algebraic equation. We are going to use these familiar counting numbers and combine with the prior knowledge. The second column, we have the solution column. Followed by the third one is the set notation. For instance, if we think of the simple equation like x minus 1 equals to 0. Basically, it has an answer which is x is equals to 1 for the solution. This is a simple example. This is still back in the number system where we have the regions of counting numbers. Here we have a set notation. The numbers are technically with the natural numbers with a symbol capital N. Another example for the algebraic equation where we have x plus 2 is equals to 0. What is the solution for this equation? The solution would be x is equals to negative 2. Now we have out of the counting numbers world. Now negative 2 is not a counting number and it is not a natural number in the technical sense of the words. We denoted it as an integer with a symbol capital Z. Another example, let's say we have 2x minus 1 equal to 0. What is the solution to this algebraic equation? The solution would be x is equals to half. What is the name for this type of solution? It is a rational numbers with the symbol capital Q. Q, which stand for, other than rational numbers, what words has to do with the symbol Q? Q for quotient or fractions, or we might say division of two numbers. Another example where we have x squared minus 2 equals to 0. What is the solution for this algebraic equation? Now we have to make use of the strategy in order to find the solution, where we have to transfer the negative 2 from the left to the right. So we will obtain x squared is equals to 2. If we simplify the situation, x is equals to plus minus square root of 2. So the solution would be x is equals to plus minus square root of 2. Now the square root of 2 is not rational numbers because we can't write it in the form of fraction and we denoted it as a irrational numbers with the symbol P, or we can say Q bar. But widely speaking, it belongs to this class of number, which is the real number.
Dia punya cerita, okay, dia punya cerita, it begins with the real number. So dalam real number, we have rational and irrational. So that is our final answer or our findings for mathematics. So we have an example So biasanya kita dapat algebraic equation macam-macam lah. So saya ambil yang simple. Okay. So you akan dapat x equals to 1, x equals to -2, x equals to 1/2, and x equals to plus minus square root of 2. So dalam solution ini, dia masih tergolong dalam real number. Okay, real number. So selepas you dah try, okay, then you have the solution. So means that you solve or you determine the value of x. So until one time, kita ada satu soalan matematik. Okay, semua soalan kita bagi, pelajar kita solve dan dapat jawapan, dan kita kategorikan dia. So number 5, we have another example.
Real solution. Let's just take us a long way where we can do a lot of maths with real number. We still have one more row to discuss. Let's say we have x squared plus 1 equals to 0. Now, using the same kind of rules and strategy, our solution would be x is equals to plus minus square root of -1. Notice that this number is not real number, and we can't measure. Unlike the square root of 2 is approximately equals to 1.4142. For the square root of -1, it is not between any numbers that we know about.
Okay, so until this part, it is still an algebraic equation. So macam biasa, kita pun solve macam biasa, transfer the 1 from the left towards the right. Then kita square root both side. Okay, so finally kita dapat ini. So if you press the calculator, so you will get math error. That's why just now we mentioned it is not a real number because does not exist math error. You cannot locate this thing on the number line, which is the real number line. Whereas for x equals to plus minus square root of 2 is around 1.4 something, 1.41 something. So maksud saya, you boleh locate di atas real number line. So that is a real number. Same goes to 0.5, -2, and 1. So for this one, 1 until 4, we can consider as real number. And then for this one, the number 5, the solution is not a real number. Maksudnya, sekarang buka lagi satu ruang. Inside a real number, we have rational, irrational. Dah dua, kita dah bincang. Semua orang pun dah faham. Sekarang kita buka lagi satu, which is not a real number. So, hopefully you can imagine, inside a square boxes, we have two circles, consists of rational and irrational. Sekarang di luar boxes tersebut, kita ada no real root atau not the real number. So not the real number, dia buka lagi satu ruang untuk orang imagine. So for mathematics, dalam dunia mathematics, everything can be solved. Kalau tak boleh solve, kita cari satu nama untuk dia. Okay? So for this case, kita continue.
Up here. Unlike for the natural numbers, integers, quotient, and real number can be represented in the number line. For the square root of -1, we can't place it in a number line. We have studied quadratic equation in the middle school. We say that.
Okay, so ini adalah salah satu benda yang manusia kaji. Faham tak? So benda itu tak boleh nak selesai. So they try to introduce something new. So dia pengguna. Ini kita panggil apa? Formula for finding the roots. Okay, formula for finding the roots. This one, where we call discriminant. Okay, discriminant. So sekarang kita nak testing lah.
That it does not exist. Do you still remember that while finding a solution of a quadratic equation by using the quadratic formula? If the discriminant b squared minus 4ac was negative, we say that there are no real roots of the quadratic equation. Based on what we have.
So hopefully you still remember discriminant, okay, where we have greater than 0, which means two distinct roots. If equals to 0, we have two equal roots. When it is less than 0, we said no real root. Macam tadi dah ternyata no real root. Okay, hopefully you still remember. So actually the discriminant is inside the formula for finding the roots. Okay, roots means that the value of x lah, when y equals to 0.
Equation. Based on what we have studied earlier, x squared plus 1 is equals to 0 will not have any real roots as the value of the discriminant is negative 4. For example, where we have ax squared plus bx plus c is equals to 0, where we have the value a is equals to 1, b is equals to 0, and c is equals to 1.
So, hope you still remember where we can find the value a, b, and c. It must refers to the quadratic equation. Okay, equation. So where we have the value a is the coefficient of x squared. The value for b is the coefficient for x. And the c is the coefficient for x to the power of 0. Maksudnya constant. So saya sudah extract the value a, b, c. Next is to substitute. Okay, substitute.
So finally, the b squared minus 4ac is equals to negative 4. And we can say b squared minus 4ac is less than 0, meaning that there is no real root.
Okay, so tercetus the idea. No real root. Means that there is a value. Okay, there is something for us to go deep to do some research. Begitulah matematik. So, kita akan continue.
Why did we do this? What was the problem here? It is easy. As the square root of the negative 1 did not exist, for us, we say that there was no solution for the equation x squared plus 1 equals to 0. However, in the 16th century, it was the mathematician named Cardan who first started to thinking about the solution of the quadratic equation with the negative discriminant.
When there is a problem, so someone will find a solution. So, Cardan ini, dia dah start fikir solution for the quadratic equation. Maksudnya ada sesuatu yang tak lengkap. Faham tak? Kita ada two distinct root, kita ada two equal roots. So, another one is tak dapat nak kira, undefined. So, dia pun start fikirlah. Okay, negative discriminant. Kemudian, Pakcik Euler ini, dia teruskan. Then dia introduce imaginary number. So, saya tak go deep inside apa proses yang mereka buat. Okay, untuk buktikan bahawa imaginary number ini wujud atau tidak.
Soon, it was Euler in the 18th century who gave the square root of the negative 1 as a symbol I and call it as the unit imaginary number. They were terms so as they were thought to be impossible and just something that we imagine. Now, you'll be able to answer the question. Can you think of the number which?
Okay, so because of Euler, they give a name. They said this thing, faham? This thing maksudnya semua orang punya masalah tentang square root of negative 1. So Euler ni kata, jangan risau. Why not we let them as a I? Okay, we let them as I. Then, cuba, you try to solve, whether can solve or not.
When the square result is a negative number, yes, it is I. If the square root of negative 1 is I, what is I times I, or we can say it I squared? It is square root of negative 1 multiplied with the square root of negative 1. That gives us negative 1.
Okay, so for this part, kalau boleh catat dalam nota UBP3 ke di mana-mana, tulislah I is equals to square root of negative 1. And then hafal perkara ini. I squared is equals to negative 1. Tulis di mana-mana sahaja helaian kertas, atas ke bawah ke kiri ke kanan, tulis I squared is equals to negative 1. So, tak perlu pergi fikir kenapa. Just that setiasa kalau nampak I squared, it is a negative 1. Nak buat hidup you senang hati. Ingat I squared negative 1. Okay?
There you go. We cut the negative number by squaring a number, and the next question was, can you find the solution for x squared plus 1 equals to 0? The answer is yes. Transferring the 1 to the right hand side, we get x.
Okay, masih sama. You transferring positive 1 from the left towards the right. So you dapat ini. Next, you nak dapatkan x. So means that you want to eliminate the square. So square root of both sides. Square root of both sides. So bila you square root both sides, you akan dapat perkara ini. So people are asking, sir, how come got positive, negative? This one very special, only exists when we square root something which is square. Faham? When we square root something of x squared, then it will have positive and negative. We will go deep into the discussion in chapter 2.3. 2.3, which is the absolute value. Okay, where I will answer why we will have positive and negative sign in the front when we are dealing with square root of something x squared. Take note, tulislah. Discuss in 2.3, absolute value. Continue. Kita pun selesai macam biasa, macam matematik biasa. But now, getting better. Because if you press the calculator, you will have math error or undefined. Sekarang Euler dah bagi tahu kita, whenever you have a look for the square root of negative 1, you let it as I.
Square equals to negative 1. Taking the square root on both sides, we get the value x is equals to square root of negative 1, or x is equals to negative square root of negative 1. That is I and negative I. So, what we learned in school wasn't incorrect. The equation has no real root. Yes, it.
So, with the introduction of the imaginary number or the unique imaginary number by the Mr. Euler, okay, so hidup kita sekarang dah senang dah, because no longer undefined math error. So the answer would be I or negative I. So maksudnya masalah kita sudah selesai lah. Okay.
It has imaginary root. That is the concept of imaginary numbers for you. But wait, we understood the concept of square root of negative 1. What if the number is square root of negative 7?
Okay, so bila kita sudah ada asas, maksudnya I is the square root of negative 1. Okay, so sekarang masalah kita dah selesai for finding the x square plus 1, the value of x. So bila tercetus idea ini, I equals to negative 1, manusia pun create lagi, banyak lagi masalah. For example, square root of negative 7. And then after this, we have square root of negative 9. So how to solve that problem related to the imaginary number. So continue.
Now, this is the second part of the lesson, which is the introductions to complex number. Previously, we have mentioned the unit imaginary number I. It is the square root of negative 1. If we square it, we will get square root of negative 1 times with the square root of negative 1, which is equals to negative 1. The square of the unit imaginary number is negative 1. Well, let us now try to work out more powers of I. What will be I cubed? Then, try it out. I cubed is I times I times I. We can write it as I squared times with the I.
In the first chapter 1.1 and 1.3, which is the indices, law of indices kata I to the power of 3, kita pun buatlah macam biasa. I times with the I times with the I. Kalau 4, I times with the I times with the I and times with the I. So same goes to I to the power 5, I to the power 6 and so on. So kalau sesiapa yang berminat, bolehlah pergi try. Okay, I to the power 3, I to the power 4 until you nampak satu pattern. Kalau you sentiasa ulang lah, you akan nampak satu pattern. Okay, so di sini saya tak go deep. Saya punya fokus adalah unit imaginary number, itu saja. So I times with the I, we have I squared. Seperti mana yang tadi saya sebut, whenever you nampak I squared, automatic negative 1. Okay, so just now soalan ni dia suruh kita buat I cube adalah apa?
Now, as the I squared is equals to negative 1, multiply with the I, and we can say that I cubed is equals to negative I. What is I? It is just an unit imaginary number, and it is...
Okay, so back to the basic. I just a unit imaginary number. Dia setakat nama sahaja. Jangan sakit hati dengan benda ini. Okay, make it simple and clear. Very simple. I adalah square root of negative 1. Sekarang kita tak pergi fikir dia wujud ke dia tak wujud. Tak perlu. Mr. Euler sudah bantu kita. Okay, dia kata benda ini wujud, sila guna. Then kita guna saja. Ini yang pertama. Yang kedua, I squared is equals to negative 1. Yang ketiga, I cube, I to the power 4, I to the power 5, I to the power 6, whatever. Yang penting, just nak bagi tahu you, dia macam indices. Then, selesai macam biasa sahaja. Continue.
This equals to square root of negative 1. Why do I keep on saying the word unit? To understand that, let's have a look at an example. What will be the square root of negative 9 be equals to? If we try out on a calculator, it would say that the input is invalid, or we can say math error.
Okay, so you nampak, you boleh try lah. Dalam dunia sebenar, kalkulator kita masih tak mampu. Faham tak? Masih tak mampu nak kira. But, this is a scientific calculator. So, that is the difference. Scientific calculator and normal calculator. Maksud saya, kalkulator kedai runcit lah. Scientific, dia boleh terima bahasa ini, which is the complex number. Okay? So temporary, we are still in normal mode. Macam ni normal mode. Calculator you pun sama dalam normal mode. So you akan dapat math error. Maksudnya, dia tak dapat bantu.
That is because most calculators are not programmed to use the imaginary number. How do we understand the square root of negative 9? How do we understand the square root of negative 9?
Okay? Remember, properties. Properties of set. Square root of P times with the Q. We can split them.
It can be written as square root of negative 9 is equals to square root of 9 multiplied with the negative 1. We know a properties of set, which says that the square root of A times B is equals to square root of A times with the square root of B. This can be written as square root of negative 9 is equals to square root of 9 times with the square root of negative 1.
Okay? So sekarang you nampak tak kenapa saya ajar 1.3 dulu? membiasakan diri. So bila saya discuss benda ini, dia akan relate to your prime knowledge. Maksudnya minggu lepas punya knowledge. Masuk ke sini, so dia macam make sense bila you belajar topik complex number. Slowly.
The square root of 9 is equal to 3. And the square root of negative 1 is equal to 9. The square root of negative 9 will be equal to 3i. This is also...
Okay? So dalam calculator, you dapat maths error. Tapi dalam dunia yang sebenar, scientific world, bila you dah berada dalam mode complex number, actually, square root of negative 9, there is a value. Okay? There is a value which is 3i. So, sudah selesai lah video yang pertama. Dia tanya tentang what is the square root of negative 9. Okay?
also an imaginary number, but it is not a unit imaginary number, as it is 3 times I. But the unit number I is 1 times with the I. Hence, it is called a unit imaginary number. The real numbers times the I is an imaginary number. For instance, this is how we would write the square.
Take note. Contoh yang beginilah. Mampu ke you express in the simplest form? Ini adalah your core business. Take note. This is your core business. You mampu untuk transform dia atau simplify dia jadi imaginary number. Take note ya.
Square root of negative 121 over 49. We will represent it as square root of negative 121 over 49. If we simplify the situation, and we will have the square root of 121 over 49 multiplied with the square root of negative 1. If we simplify the situation, we will have the square root of negative 121 over 49 is equals to 11 over 7 multiplied with the I. It is a real number times with the I. So the numbers like 0.145i and 16.25i are imaginary numbers. Previously, we have learned about the square of a negative number. It involved using a new number I which is equals to the square root of negative 1. These numbers are called imaginary numbers, and it could be in the form of bi, where b is a real number, and I is equals to the square root of negative 1. Numbers like I, 2i, negative 4i's are all imaginary number. What if we have a numbers like 3 plus 7i? Will this be an imaginary number? Well, we can be sure that this part of the number is imaginary, and this part is a real number. So this is a mix of a real and imaginary part. And this is what we call an example of complex number, where we have the real plus with the imaginary number and give us a complex number. It is of the form of a plus bi, where a and b are real number, and I is the unit imaginary number. Now, let's play around with the basic form. Observe that when a is equals to 0, what is left will be an imaginary number, which is the bi. When b is equals to 0, we only have a real number, which is the a, plus with the 0i. So, what are the real and the imaginary part in the basic form of a complex number? A is called a real part, and b is called the imaginary part. That is basically the introduction for the imaginary number and the complex number.
Tadi you sudah tengok video macam mana terhasil imaginary number, or we can say unit imaginary number. And then after that, you diperkenalkan complex number. So dalam complex number ada dua elemen, which is the real and imaginary part. Kemudian dia ada sedikit situasi tentang which one is a real number, which one is an imaginary number. Dia ada certain criteria. So sekarang kita tengok BPT kita 1.2. So we have a complex number. So bila kita sebut complex number, atau you baca apa-apa soalan, when they mention complex number, Z is equals to A plus BI. Dalam otak you, make it simple. Nampak perkataan complex number, tulis Z equals to A plus BI. Tanpa fikir. Nampak complex number, atau nampak Z, atau nampak A plus BI, it is the same thing, which is the complex number. Ulang, nampak perkataan complex number, you tulis Z equals to A plus BI. Nampak Z, you tulis A plus BI. Nampak A plus BI, then you fikir complex number, then you tulis Z. Itu saja. Saya suka A plus BI. Okay? Kalau you tengok buku-buku yang lain, dia akan express X plus YI atau X plus IY. Semua adalah benda yang sama. So dalam kelas saya akan guna A plus BI. Okay. So we call it complex number and is written in the Cartesian form. Okay, Cartesian form. So, bila kita sebut tentang Cartesian, lesson ini kita akan bincang dengan deep petang nanti. 2 to 3. Okay? So, you just ingat Cartesian form for the complex number, which is the A plus BI. So, for the complex number, A plus BI, okay, complex number, A plus BI, kita panggil apa? Kita panggil A plus BI lah. Okay, complex number. So, where B, X, Y, semua ini mesti real number. Okay, syarat dia mesti real number. Kalau bukan real number, jawapan salah. Mesti. Okay, so repeat. Saya tak kata this part saya tak kata this part, saya just kata ini. B and Y, A and B must be real number. So ini adalah hint. Kalau jawab apa soalan pun, kalau dia bukan real, confirm salah. Next, kita fokus lagi kawasan ini. This is what we call the real part. Okay, and then for this one, BI, BIYI, we call it imaginary part. Kena tahu. Selepas kelas pagi tadi, sejak nanti pukul 9, you must know what is Z, what is complex number, what is Cartesian, what is real part, what is imaginary part. So, I is a unit imaginary number. Tulis unit imaginary number. Okay? At the same time, I is a unit imaginary number. Then I is equals to square root of -1. Tambahan, I squared is equals to -1. I cube is equals to negative I. Okay? Kalau I to the power 4, fikirkanlah, I to the power 4 equals to 1.
Negative 1.
No, it's 1. It's 1. Okay? So, tulis. Catat je. Dan kalau boleh, hafal. Z is a real number. Real number. And can be written as Z is equals to A plus 0I. Catat ini nota yang penting. Z is an imaginary number, then kita tulis Z is equals to 0 plus BI. Settle? Faham ah? Okay. Next, kita pergi ke conjugate. So, kalau you tengok video, memang dah ada tentang conjugate. So, conjugate ni, you pernah dengar kan? Ketika cert question 15 for BPT1. Ingat? Conjugate. So, what is the usage of conjugate? When we multiply with the conjugate, kita akan dapat apa? Kalau you masih ingat. So, the answer will be from the irrational to rational. Jika masih ingat. Catatlah ya. Focus conjugate adalah from Q bar to Q. Itu adalah untuk square root atau set. Okay. So kalau untuk ini pun sama, dia akan jadi from the complex number to rational. From complex number, dia akan jadi rational. So kalau untuk set for irrational, jadi rational. Kalau complex number from the Z, which is the complex number, dia akan jadi ke rational, or we can say it real number. Itu tugas conjugate. Okay? Boleh? So, you baca ayat ini, conjugate of the Z. Conjugate of the Z. Tadi sudah sebut, bila saya sebut Z, maksudnya A plus BI. Conjugate of the Z. You boleh tulis Z asterisk atau Z bar. So the answer for the conjugate, A minus BI. So observe, the difference is the sign. Okay, the difference is the sign. So kita tengok contoh. Complex number of Z. So we have Z. Conjugate dia, tukar sign dia. Fokus betul-betul. Siapa punya sign berubah. So, sepatutnya, saya nak you tulis your own word lah. Generalize. Perkara ni, you kan suka buat keputusan awal. Betul? Tapi ingat, dalam matematik matrikulasi, jangan buat satu contoh, lepas tu buat kesimpulan. Oh, mesti macam ni. No. Tak boleh ya. So, generalize. Buat conclusion. For the situation, Z and the conjugate of Z. So, dengan itu, saya kata reverse. Harap fahamlah. Terbalikkan. Reverse the sign of imaginary part. So, kalau you tengok betul-betul, memang pun saya fokus imaginary part sahaja. Nampak? Kalau negatif, jadi positif. Kalau positif, jadi negatif. Kalau negatif, jadi positif. Yang depan, tetap sama. Tidak berubah. Okay? Tidak berubah. So, sekiranya saya nak perangkap you, biasalah saya letak macam ni. Pelajar, dia akan tulislah negative 2i plus 1. No. Tengok ayat dia, reverse the sign of the imaginary part. Apa-apa pun mesti A plus BI. Walaupun BI plus A. Jangan terperangkap, ingat tengah-tengah saja yang berubah. Kita fokus on imaginary part. Harap faham. So bila you jawab matematik dalam matrikulasi, you perlu buat general situation. Okay, itu satu. Kemudian kalau boleh, you belajar lagi macam mana nak buat general case. Sebagai contoh, Z is equals to A plus minus BI. So this is what we call general case. Maksudnya bentuk dia mesti macam ni. Okay, kalau dia punya conjugate, saya pun tulislah Z bar is equals to A, sini ada BI. So saya fokus, if here we have positive, here must be negative. If here we have negative, here we must have a positive. That's why we said reverse the sign of the imaginary part. Boleh ikut? Inilah dia. So, ini kita panggil bank of strategy. Catat benda yang baru, bank of strategy, which is the conjugate. Okay, perlu catatlah, bank of strategy. Okay, number one, conjugate. So kalau nak tulis, boleh tulislah Z to real number atau kita panggil rational. Number one. Next, kalau dah faham conjugate, next kita focus on operation. So dalam matematik, we have 4 operation. Tambah, tolak, darab, bahagi. Okay? Kejap nanti, sebelum pukul 9, tambah, tolak, darab. 3 benda. So, question number 6. Very simple. You dah belajar masa Form 3, Form 2, Form 4, Form 5. If you still remember what is like term, what is unlike term. Operation plus and minus. So this is the real part. Real. So real plus with the real. So we have 10. Imaginary and imaginary. So we will have the answer for imaginary. Tambah. Next, subtraction. Real part minus real part. So we have -4. Imaginary minus the imaginary. So minus positive. So we will have 10i. Tambah, tolak. Okay, continue lagi. Benda-benda yang sama. Real part plus real part. So we have 1. Imaginary part. So -3 plus 5. So we have 2. Okay. Then subtraction. Real part minus the real part. So we have -7. Imaginary part, 4 minus become plus lah. So 4 plus with the 5, so we have 9i. Simple. So kena belajar macam mana nak buat general. Okay, general statement, general conclusion. So please state the operation involved in question 6A and 6B. So kalau you tengok 6A, the operation is addition. Okay. 6B, the operation is subtraction. You tulislah addition and subtraction for complex number. Next, dia kata generalize the situation on A and B. Makna dia, apa yang telah anda lakukan? Pelajar kita dia tahu, ini tambah ini, dapat ini. Ini apa? Itu apa? So, biasakan diri dalam matematik. Okay, biasakan diri. Maksudnya dalam matematik saya lah. Nyatakan kata kerja, kata nama. Apa yang you buat? I mean the nouns and the verb. Every action, there must be a name. Kalau you nak improve matematik. The sum of real part. Saya jumlahkan real part. And the same process for imaginary part. Makna dia, saya jumlahkan bahagian real dengan real. Saya jumlahkan bahagian imaginary dengan imaginary. That is what we call the general statement for this situation. Kalau you sentiasa buat begini, automatic matematik you akan hebat. Okay. So finally, write the rules in general case. Ni saya ambil contoh. A plus BI, C plus DI. Kenapa A, B, C, D? Sebab saya nak bagi tahu tidak semestinya sama. Nampak? Nilai dia tak semestinya sama. Kadang-kadang sama, tapi kita anggap dia berbeza. So, tadi saya sudah buat statement. Sum of the real, sum of the imaginary. So, kalau you nampak, this is what we call the sum for the real part. Okay, this is what we call the sum for imaginary part. Beginilah kita belajar matematik. So, kalau untuk page 4 ini, you tengok semula, complex number. Pagi ini, sehingga pukul 9, saya jawab apa? You mesti kena tahu, what is complex number? What is real? What is imaginary? What is Cartesian form? Siap. Next part, what is I? I equals to square root of negative 1. What about I square? Negative 1. Next, bahagian 3. What is conjugate? What is the function, okay, of having a conjugate? Fokusnya from the complex, we want to change to real number or rational number. Itu guna conjugate. What is conjugate? Focus on the imaginary part. Reverse the sign. If given is a negative, then reverse the sign, become positive. Only focus at the imaginary part. Part number 4, operation. We have been discussed about addition and subtraction. So remember, real and the real, imaginary with the imaginary. So itulah untuk pagi ini sampai pukul 9.